A coil of resistance 400 ohm is placed in a magnetic field. If the flux linked with the coil varies as phi is equal to 50 t square plus 4, current at 2 seconds is. So first calculate E. E is equal to d phi by dt, that is equal to d by dt of, what is flux? Flux is 50 t square plus 4. So if I differentiate this one, this is constant, so 50 into t square differentiation is 2t plus differentiation of a constant is 0, that is equal to 100t. So E is equal to 100t. Now E I is equal to E by R. So we write E is 100 into current at 2 seconds we want. So this is 2 by, what is the resistance? Resistance is 400 ohm. So by 400, so 2 zeros gets cancelled, 2 ones are 2 twos are, that gives us 1 by 2, which is equal to 0.5. This is current, so ampere, so that's the answer, 0.5 ampere. In a coil, the resistance is 10 ohm. The induced current developed by changing the magnetic flux through it is shown in the figure as a function of time. The magnitude of flux, the magnitude of change in flux through the coil is, we have to calculate change in flux. Now E is equal to d phi by dt. Then we want d phi is equal to E dt. So E is equal to, E is potential difference, which is EMF, which is equal to IR. So I into dt into R. This IDT is nothing but the area of this triangle. Area of the triangle is half into base into height. Half into base is 0.1 into height is 4 into, this is IDT gives the area of the triangle, and then into R. What is the resistance? Resistance is 10 ohm. So that's 2 to the 4. So that is equal to 2. The change in flux, this is in Weber. The magnetic flux linked with the coil satisfy the relation phi is equal to 60 square 4t square plus 6t plus 9 Weber, where t is the time in seconds. The EMF induced in the coil at t is equal to 2 seconds is. Now EMF induced is equal to d phi by dt, that is equal to d by dt of 4t square plus 6t plus 9, that is equal to 4 constant, differential of t square is 2t plus 6, that is equal to 4 to the 8 into t. T is 2 seconds, so in place of t I will write 2 plus 6, that is equal to 16 plus 6, that is equal to 22 volt. The north pole of a bar magnet is moved towards a coil along the axis passing through the center of the coil perpendicular to the plane of the coil. The direction of the induced current in the coil when viewed in the direction of motion of the magnet is. So we have a coil. To this coil a magnet is pushed into this. This is north pole of the magnet, this is south pole of the magnet, and it was pushed into it like this. Now, so if you push a magnet in this direction, then it creates north pole here. creates north pole means the current will be moving in anti-clockwise direction, because here it will create a north pole, so the current will be in anti-clockwise direction. The flux associated with the coil changes from 1.37. The flux associated with the coil changes from 1.35 Weber to 0.79 Weber in 1 by 10 seconds. Then the charge produced by the coil, if the resistance of the coil is 7 ohms is. Now first of all we have to calculate E. E is equal to d phi by dt. So E is equal to, change in flux is 1.35 minus 0.79 by time. Time is 1 by 10. So 1 by 10. So E is equal to 0. 1.35 minus 0.79 is 0.56. This 1 by 10, this 10 goes up, so that is into 10. Now we got E. Once I got E, then I will write E is equal to IR. IR is equal to 0.56 into 10. Then I is equal to Q by T. So Q I will write here, Q by T. The T I will write here, 0.56 into 10 into this Q by T. This T goes here, so this is 1 by 10, and this R goes in the denominator. So R, actually you have Q by T. I is equal to Q by T into R. So R, I brought it here, T went here. Okay, so R is how much? Resistance is 7. This 10 and 10 gets cancelled, 0.8 times. So Q is equal to 0.8 coulomb. The magnetic flux linked with the circuit of resistance R changes by delta phi in time delta t. Then the total quantity of charge that passes at any point in the circuit during the time delta t is. Now E is equal to d phi by dt. Now this we write it as E is equal to delta phi by delta t. E is equal to IR. E is equal to IR is equal to delta phi by delta t. Now I can be written as Q by delta t, or delta Q by delta t, into R is equal to delta phi by delta t. Now this delta t gets cancelled, so this charge Q is equal to delta phi by R. So here delta phi by R. An infinitely long cylinder is kept parallel to an uniform magnetic field B directed along positive z-axis. The direction of the induced current as seen from the z-axis will be. Now it is kept in the magnetic field, uniform magnetic field, so it produces constant flux. There is no change in flux, so induced EMF is 0, so the induced current is 0. If a coil of a metal wire is kept stationary in a non-uniform magnetic field, then say this is a non-uniform magnetic field, radial magnetic field. So here magnetic field will be like this. Now in this I placed a coil. If I place a coil and the coil is stationary, so the magnetic flux remains same. Even though the field is non-uniform, the magnetic flux remains same with respect to time. So EMF is not induced because the flux is constant, because the coil is stationary. The flux is remaining same. As flux remains same, no EMF is induced, so no current is induced. A coil having N turns and a resistance R ohm is connected with a galvanometer of resistance 4R ohm. This combination is moved in time t seconds from a magnetic field W1 Weber to W2 Weber. The induced current in the circuit we need to calculate. Now know that E is equal to d phi by dt. IR E is equal to IR is equal to d phi by dt. Then I can write I is equal I is equal to, so here n d phi by dt, as you have n turns, but this n turns he wrote it as small n. He gave in the question that it is small n, so here I am writing it as small n d phi by dt. So I is equal to n into d phi by dt, and this r I will write here. Okay, so I get I is equal to n into d phi is change in the flux, which is W2 minus W1. So that's W2 minus W1 by R is R ohm plus 4R, so total is 5R. So that is 5R into time is T. So N into W2 minus W1 by 5RT. A straight conductor of length 4 meters moves with a speed of 10 meters per second. When a conductor makes an angle of 30 degrees in the direction of magnetic field of induction 0.1 Weber per meter square, then the induced EMF is, this is motional EMF. Motional EMF formula is BLV sin theta. So B value is 0.1 into length is given, right? Yeah, 4 into velocity is 10 into 1 by 2, that is equal to 2 volts. A metal circular plate of radius r is rotating with uniform angular velocity omega with its plane perpendicular to the magnetic field B. Then the EMF developed between the center and the rim of the plane is half B omega r square. So it is omega br square by 2. A rod of length 20 centimeters is rotating with an angular speed 100 rps in a magnetic field strength 0.5 Tesla about its one end. What is the potential difference between the ends of the rod? So in a magnetic field it is rotating. This is the point, and it is rotating in the magnetic, it is rotating in the magnetic field. In this magnetic field it is rotating it like this. Now we have to calculate the potential difference. That means E is equal to, what is the formula? Half into B omega L square is our formula. So half into B L square. Omega is 2 pi F. So this 2 gets cancelled. B value is 1 by 2, length is 20 centimeters, 20 into 10 power minus 2 whole square into pi is 3.14 into frequency is 100 rotations or revolutions per second. So that gives me 400 into 10 power minus 4 into 3.14 into 100. So this 100 10 power minus 4 get cancelled. So this is 2 into 3.14 is 6.18 volts. Oh, sorry, 6.28. 2 into 1 is 2. 6.28 volts. A 2-meter wire is moving with a velocity 1 meter per second perpendicular to the magnetic field 0.5 Weber per meter square. The EMF induced in it will be, the EMF induced E is equal to BLV. So B is 0.5 into L is 2 meters, velocity is 1, so this is 1 volt. Shown in the figure is the circular loop of radius r and resistance capital R. A variable magnetic field induction B is equal to B naught e power minus 1, which is equal to B is equal to B naught by E, is established inside the coil. If the K is closed, now we closed it, the electrical power developed right after closing the switch is equal to, right after closing the switch, so when the time is very less, we know that the power P, is equal to B square A square by R, that is equal to, now we know that B is equal to B naught by E, so this is B naught square by E square. A is pi R square whole square by capital R. So this gives us B naught square pi square R power 4 by R. Now this is 1 by E square. 1 by E square is E power minus 2, nearly equal to 1. So B naught square pi square R power 4 by R. A current I is equal to 10 sine 100 pi t ampere is passed in the first coil, which induces a EMF 5 pi volt in the second coil. The mutual inductance between the coils is I is equal to 10 sine 100 pi t. We compare this with I is equal to I naught sine omega t, where I naught is equal to 10, omega is equal to 100 pi. E is equal to m into di by dt. This is our formula. Now E is equal to m into d by dt of I naught sine omega t, which gives us m into I naught constant omega into cos omega t. This is E. Now it said maximum EMF. Maximum EMF, if this EMF has to be maximum, then cos omega t has to be maximum. Maximum value of cos is 1, so it is m into I naught into omega. this Emax value is 5 pi volt. So this is 5 pi, that is equal to M into I naught value is 10, omega value is 100 pi. This pi gets cancelled. This is 10 power minus 3. So that gives us M is equal to 5 into 10 power minus 3 Henry. So this is M is equal to 5 milli Henry. That's our answer for. Two coils A and B having turns 300 and 600 respectively are placed near each other. On passing a current of 3 ampere in A, the flux linked with A is 12 into 10 power minus 4 Weber, and with B is 9 into 10 power minus 5 Weber. The mutual inductance of the system is. Now let us consider that this is coil A and this is coil B. The coil A current passing is 3 ampere. And flux in A is 1.2 into 10 power minus 4 Weber. Flux in B is 9 into 10 power minus 5 Weber. When you pass current here, it produces magnetic field. This magnetic field, as current is changing, the magnetic field will change, creates flux. Change in flux creates induced EMF, or induced EMF in turn creates induced current. So the change of flux in B is directly proportional to the change in current in primary coil, that is A. So the flux is equal to M into I. So M is equal to flux in B by I. Flux is 9 into 10 power minus 5 by I is 3 ampere. So 3 3s are 9. So that is 3 into 10 power minus 5 Henry. A small square loop of wire of side L is placed inside a large square loop of wire of side L. The loop are coplanar and the centers coincide. The mutual inductance of the system is proportional to. We have squares. First one is bigger square. This is one square. Right. Whose side is L. There is another smaller square. Another smaller square here. Whose length is small l. Okay. Now this is the common center for both of them. This distance is L by 2. L by 2. Here the angle is 45. Here the angle is 45. Now let us assume that current I is flowing through this one. Then the magnetic field due to this current at the center is equal to B is equal to mu naught by 4 pi into I by R. R is the distance is L by 2. So here I will write L by 2 into sine 45 plus sine 45. So that is equal to mu naught by 4 pi I by L 2 into 2 by root 2 is root 2 root 2. So this is 2 root 2 mu naught by 4 pi I by L. Now we have four sides, one, two, three, four sides. So the total B is equal to 4 times of the net B is equal to, this is only due to the side of length L. So that is 4 times of B, that is 4 into 2 root 2 root 2 mu naught by 4 pi into I by L. Right. Now, so due to this magnetic field, we'll have flux in the smaller loop, small l. So the flux in the smaller loop is directly proportional to the current in the outer loop or bigger loop. So the flux in the smaller loop is B into A. This is B, this is B. Just write B net into A. A is this side is L, so this is B L square is equal to, this is mutual induction M into I. What B net value is, we'll write the value of B net. Its value is mu naught by 4 pi I by L into 4 into 2 root 2. Okay, you can write 8 root 2 also. M into I. So M into I, this L square is there, no? So I'll write L square. Now this I and this I gets cancelled. So we get M. Now he was saying the M is directly proportional to, now mu naught by 4 pi is a constant value, 4 and 2 root 2, this is a constant value. So this is small l square by capital L is directly proportional to M, or M by directly proportional to L square by L. So second option is correct. What is the self-inductance of a solenoid of length 31.4 centimeters, area of cross-section 10 power minus 3 meters square, and the total number of turns 10 power 3? Now we know that flux is equal to Li. Okay, so flux B into A is equal to Li. Now the magnetic field due to the solenoid is mu naught Ni. Mu naught Ni into A is equal to L into I. Now this I and this I will get cancelled. Here we write mu naught number of turns per unit length into area is equal to L. Let's now substitute these values here. L is equal to mu naught is 4 pi into 10 power minus 7 into number of turns, or total number of turns are 10 power 3. 10 power 3. So this is 10 power 3 into area is 10 power minus 3 by length is 31.4 centimeters, 10 power minus 2, that is equal to, how much we would be getting, 10 3 10 power minus 3, pi is 3.14, so this is 10 times, so we get 4 into 10 power minus 3 Henry, that is equal to 4 millihenry. So 4 millihenry, first option is correct. A long solenoid has 1000 turns. When a current of 4 amperes flows through it, the magnetic flux linked with each turn of the solenoid is 4 into 10 power minus 3 Weber. The self-inductance of the solenoid is. The self-inductance of the solenoid is. Now we know that flux is directly proportional to current, so flux is equal to Li. So L is equal to flux by I. Now if you have n turns, then we will write n phi. So that is equal to 10 power 3 into flux is 4 into 10 power minus 3 by current is 4 ampere. 4 gets cancelled. 10 power minus 3, 10 power minus 3, 1 Henry. A coil of N is equal to 100 turns, I is equal to 4 amperes, creates a magnetic flux 10 power minus 5 Tesla per meter square per turn. The value of the inductance is. Now N phi is directly proportional to I, so N phi is equal to Li. L is equal to N phi by I. N is 100 turns into phi is 10 power minus 5 by 4, that is 1 by 4 into 10 power minus 3, that is 0.25 millihenry.